We are covering centroids, moments of inertia, and friction, three core topics from the statics section of the NCEES FE Civil Reference Handbook. These concepts are fundamental and frequently tested, so mastering them is crucial for passing the exam. Let's begin with centroids of composite areas. The exam will present you with a shape made of several simple geometric components, like rectangles and triangles, and ask for the location of its centroid. You'll use the formulas found in the handbook, which define the centroid's x and y coordinates as the weighted average of the component centroids. A very common exam trap is to include a cutout or a hole in the composite shape. You must treat this removed area as a negative value in your summation for both the area and the weighted centroid calculation. Forgetting this sign convention is an easy way to lose points. Next, let's discuss the moment of inertia, which quantifies a cross-section's resistance to bending. For composite shapes, you cannot simply add the moments of inertia of the components. You must use the parallel axis theorem. This theorem, I equals I sub c plus ad², is non-negotiable. You have to know it. The term I sub c is the moment of inertia of the individual component about its own centroidal axis, which you'll find in the handbook tables. A is the area of that component, and d is the perpendicular distance from the component's centroid to the overall composite centroidal axis. A frequent mistake is forgetting the ad² term entirely or using the wrong distance for d. Always calculate the composite centroid first before attempting the moment of inertia calculation. Now, let's shift to friction. The FE exam will test your understanding of the difference between static and kinetic friction. Static friction is the force that prevents an object from moving, and it's a variable force up to a maximum value of the coefficient of static friction, μs, times the normal force. Kinetic friction applies once the object is in motion and has a constant value of the coefficient of kinetic friction, μk, times the normal force. A classic exam problem will give you both coefficients and an applied force, then ask you to determine if the object moves. You must first calculate the maximum possible static friction force. If the applied force is greater than this maximum, the object moves, and you must then use the kinetic coefficient for any further calculations. Another key friction topic is belt friction, governed by the formula T2 over T1 equals e to the power of mu beta. T2 is the larger tension resisting motion, T1 is the smaller tension, mu is the coefficient of friction, and beta is the angle of rap. The most common trap here is the unit for beta. The exam will often provide the rap angle in degrees, but the formula requires it to be in radians. Always perform this conversion. To help remember the parallel axis theorem, use this mnemonic, Ic Ad². This reminds you that to get the total moment of inertia, I, you must see the component's inertia, Ic, and then add the ad² term. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.